Good morning to all of you. In the wave optics, the first problem we are solving, monochromatic light of wavelength lambda. Wavelength is represented by lambda. So lambda is equal to 589 nanometer is incident from air onto a water surface. So here, what is the wavelength lambda? Frequency and speed of the reflected light. So we are talking about the reflected light. So on the surface, whenever water is there, when the ray of light is incident, a part is refracted as well as reflected. So how much light is falling as incident ray, the same light is reflected back. Okay. Now here we have to calculate the reflected light. So here they are given lambda value 589 nanometer. So this one we are writing as 10 to the power of minus 9 meter. Okay. And the refractive index they are given as 1.33. Nu is equal to 1.33. Okay. So first problem, what is the formula we have to write it? Whenever the ray of light is passing, the frequency of light will be changed. So how much light? V is equal to nu lambda. V is nothing but C. C is equal to nu into lambda. So nu is equal to C divided by lambda. C means velocity of light, 3 into 10 to the power of 8 meter per second. So I'll write here to understand. C is equal to 3 into 10 to the power of 8 meter per second. Okay. And then next lambda wavelength is 589 nanometer. So nanometer I can write as what? 10 to the power of minus 9 meter. So the value is 3 divided by 589 into 10 to the power of 17. Okay. Now here what is the value? We can get it as 3 divided by 589. 3 divided by 589. We get the value as I am writing the value as 5.09 into 10 to the power of 14. So this is the frequency, this value is hertz. Okay. So wavelength will be the same, refractive index, velocity of light, frequency is this much value. Now we are talking about the refracted light. When you are talking about the refracted light, the frequency of light does not depends upon the property of the medium. Frequency of light does not depends upon the property of the medium when it is traveling. Okay. So how is the speed of the light related to the refractive index? Okay. So here what I should write it? So for the V is equal to C by nu. V is equal to C by nu. So here C means 3 into 10 to the power of 8 meter per second. Nu is the refractive index, nothing but 1.33. 1.33. So therefore the meaning is 3 into 10 to the power of 8 divided by 133 by 100. So this value we can write as 300 divided by 133 into 10 to the power of 8. 10 to the power of 8. So here V is equal to 300 divided by 133 is 2.26 into 10 to the power of 8 meter per second. So this is the velocity, the speed. V is equal to 2.26 into 10 to the power of 8 meter per second. Now, wavelength of the light in water. Wavelength of the light in water. How much? So here wavelength of light in water. Wavelength of light in water. So what is the formula? We have to write it. So here wavelength means lambda v by nu. So velocity is how much? 2.26 into 10 to the power of 8 divided by nu. How much you got it calculation? 5.09 into 10 to the power of 14 hertz. Okay, so this is the wavelength we have to calculate. So here the meaning is we get as 2.26 divided by 5.09. We got as 0.444. So we got as 0.444 into 10 to the power of, if it comes up, what happens? Minus 6. Minus 6. So here what I should write? 444 divided by 1000. Up it comes, what happens? Minus 9 kH. Otherwise, to understand, what I should write? Minus 6 divided by 1000. So 444 into, if it comes up, 10 to the power of minus 3, 10 to the power of minus 6. So what I should write? 444 into 10 to the power of minus 9 meter. 10 to the power of minus 9 meter. So here what I should write at 10 to the power of minus 9 can be written as 10 to the power of minus 9 can be written as. So here I am writing lambda value, you got it as 444 into 10 to the power of minus 9 meter. So lambda is equal to 444 nanometer. We can write as 444 nanometer. So from here we got the speed. Okay, v this much, lambda also we got it, and we have calculated the frequency also. Okay, now in the wave optics third problem, the second problem is the theory you can study. So in the third problem, the refractive index of the glass is 1.5. So the refractive index of the glass is 1.5. So what is the speed of the light? Speed of the light is represented by v, and in vacuum the speed of the light vacuum is given as 3 into 10 to the power of 8 meter per second. 3 into 10 to the power of 8 meter per second. So what is the relation? Speed of the light in glass, what is the value? So this is I am writing as speed of the light in glass. Okay, so what is the formula we have to write it? V is equal to here refractive index of the glass is 1.5. So V is equal to nu lambda. Okay, so here what is the value we can write it as? In other words, what is the relation? We can write as V is equal to C by nu. This is the relation. So C is nothing but 3 into 10 to the power of 8 divided by nu is nothing but 1.5. So 30 divided by 15 into 10 to the power of 8. So 15 ones are 15 twos are. So V is equal to 2 into 10 to the power of 8 meter per second. So this is the velocity of light in glass. The speed of light in the glass is nothing but what? 2 into 10 to the power of 8 meter per second. Now this is the third problem of second bit. This is also theory. Is the speed of the light in glass is independent of the color of light? If not, which of the two colors, red and violet, travels slower in a glass prism? So here what is the answer? The speed of the light in the glass is not independent to the color of light. It is not, speed of the light is not independent. The refractive index of a violet component of white light, okay, is greater than the refractive index of a red component. Okay, Then what we can see that the speed of the violet light is less. Speed of the violet light is less than the speed of the red light in glass. Therefore, violet light travels slower than the red light in the prism. Now, this is the fourth problem. Very important problem. This type of problems will come in the exam. This type of problems will be coming in the exam. So here, in Young's double slit experiment, we had studied the theory YDSE. Okay, the slits are separated by 0.28 millimeter. So here, how is the figure we have to see? So this is the slit. So the distance between the slits is nothing but small d. Small d is 0.28 millimeter. So what is the meaning of this one? Distance d is equal to 0.28 into 10 to the power of minus 3 meter. Okay. Next, the screen is placed. So this is the screen. So the distance between the slit and the screen is nothing but what? Capital D. So here capital D value is 1.4 meter. Okay, away. The distance between the central bright fringe means what? The source is passing. So this is the central bright fringe. Central bright fringe and fourth bright fringe means what? This is the fourth bright fringe. So the meaning is n is equal to 4. Okay, and is measured from here to here. This is the bright fringe and this is the fourth fringe. It is measured is nothing but x. So x is equal to, what is the value they are given? 1.2 centimeter. So x is equal to 1.2 into 10 to the power of minus 2 meter. Okay. Determine the wavelength of light used in the experiment. Determine the wavelength of light means what? Lambda is equal to question mark. Lambda is equal to question mark. So what is the formula we have to apply? What is the formula? So x is equal to n lambda d divided by small d. N lambda d divided by small d. Now in this one, x is equal to n lambda d divided by d. So everything was given. So what we have to calculate? Only the lambda value we have to calculate. So here what I should do is, I am rubbing the figure, not necessary. So here lambda is equal to x into d divided by n into d. X means what? 1.2 into 10 to the power of minus 2 into small d. Small d means what? Small d is 0.28, 0.3 meter. Okay. So what I should write? 0.28 into 10 to the power of minus 3 divided by, what is n? N is what? 4 into capital D. Capital D is what? 1.4. Okay. So what is the value you should write? 4 ones are 4, 0.3. 0.3. So in this one, what is the value we should write? Now here lambda is equal to 3 by 10 into 10 to the power of minus 2 into 28 by 100 into 10 to the power of minus 3 into 1.4. Okay. So what is the value you should write? 3 8s are 24, 2, 3 to the 6, 7, 8, 84. Okay. And 10 to the power of minus 2, 10 to the power of minus 3 is nothing but 10 to the power of minus 5. And here what is there? 10 to the power of 3. And here what is there? 1.4. So what is the value you should write it as? 84 divided by 1.4. 1.4 can be written as 14 by 10. So 14 by 10 means 0. This is 14. And if it comes up, what happens? 10 to the power of minus 5 into 10 to the power of minus 3. 10 to the power of plus 3 comes there into the numerator, 10 to the power of minus 3. So what is the value here? 14 6 are 84. So 60 into 10 to the power of minus 8. So what is the value you should write? This is nothing but meter. So lambda is equal to 6 into 10 to the power of minus 7 meter. 6 into 10 to the power of minus 7 meter. So to write in terms of the nanometer, what we have to do it. So what I am writing? 600 divided by 100 into 10 to the power of minus 7 meter. So what is the value? You can write it as 600 into 10 to the power of minus 9 meter. So what is the lambda value? 600 nanometer. So this is the wavelength they had asked in the YDSC experiment. Now fifth problem. The question: in Young's double slit experiment, using monochromatic light of wavelength lambda, the intensity of light at a point on the screen where path difference is lambda is k units. What is the intensity of light at a point where the path difference is lambda by 3? So what is the given first thing? Monochromatic light of source of wavelength is lambda. So what is the Young's double slit experiment? This is screen. So from here source S1, the light is passing. Here also source S2, light is passing. This is the point P, what we had studied. So here, first monochromatic source means single source of light. So here we are assuming as I, here also I. So we had studied in the theory, in the note, what is the formula for the resultant intensity? IR is equal to I1 plus I2 plus 2 root of I1 I2 cos phi. This is the formula what we had studied. Okay. So here intensity of wavelength they are given as wavelength lambda. The intensity of light at a point on the screen where path difference is lambda is k units. So this is nothing but lambda is nothing but k units. Okay, what is the intensity of light at a path difference is lambda by 3. So here path difference is assumed as delta x is equal to lambda, and here path difference they are given as what? Lambda by 3. Okay. Now here what happens? What we have calculated? Resultant intensity. I1 is I plus I2 is also I plus 2 into root of I1 I2 I into I. So this is I into I cos phi. Okay. So here in this one what I should write? I plus 2 into I. But what is I into I square? I into I is nothing but I square. Root of I square is I. So cos phi, what is phi? So what is the phi? Phi is nothing but phase difference. So what is the formula for the phase difference? So here phase difference is equal to 2 pi by lambda into path difference. Path difference. So path difference we are assumed as what? Delta x. So delta x what is given? Lambda. So what I should write? 2 pi by lambda into path difference is lambda. Lambda lambda cancel. So what is the value here? Nothing but 2 pi. So cos 2 pi. So cos 1 pi is minus 1. Cos 2 pi is 1. Okay. So what is the value you should write? I plus I is nothing but 2i plus 2i. Cos 2 pi is 1. So what is the value? This is nothing but 4i. So IR is equal to 4 into I. Next, here what is given? Intensity of light is nothing but k units. They are given as k units. So here resultant intensity is k. K is equal to 4i. So what is the intensity? Is nothing but k by 4. Intensity is equal to k by 4. Now here what is the intensity of light at a point where path difference is lambda by 3? So what is the resultant intensity we have to calculate? So here Phase difference, let us assume this is delta phi. So 2 pi by lambda into path difference. Path difference, what is given? Lambda by 3. So here I am writing as lambda by 3. Lambda, lambda cancel. Therefore, this is nothing but 2 pi by 3. Okay. So this is nothing but 2 pi by 3. Okay. Now I'll write up better. So delta phi is equal to 2 pi by 3. Now here, so here what I should write? Path difference. So phase difference is delta phi, you got it. So what is the formula? Resultant intensity is nothing but I plus 2 into root of I into I cos 2 pi by 3. So what is the answer? Resultant intensity is nothing but 2I plus 2I, I square is I, cos 2 pi by 3. Cos 2 pi by 3 means 3 ones are 360s are. So cos 120. Cos 120 is minus 1 by 2. So here what I should write? Minus 1 by 2. So 2 cancel. 2I minus I is nothing but I. 2I. So therefore what is the value? IR is equal to I. So here what I should write? So IR is equal to I. So here what is given here in the previous question? I is nothing but K by 4. So the resultant intensity in terms of K is nothing but K by 4. This is a value. Now, sixth problem. A beam of light consisting of two wavelengths. So here lambda 1 is 650 nanometer. So 1 nanometer is equal to 10 to the power of minus 9 meter. 10 to the power of minus 9 meter. Now here 10 to the power of minus 9 meter. Next, here lambda 2, they are given as 520 nanometer. So 10 to the power of minus 9 nanometer is used to obtain interference fringes in a wide ESC Young's double slit experiment. So what is the distance of the third bright fringe? Distance is nothing but x is equal to question mark. Third bright fringe means what? N is equal to 3. On the screen, from the central maximum for wavelength of 650 nanometer, means for this one they are asking the value. So what is the formula we are to write it? X is equal to n lambda d by small d. So here what I should write? So this is lambda 1. So 3 into lambda 1. Lambda 1 is how much? 650 into 10 to the power of minus 9 divided by into what? D divided by small d. So this is the value. So what I should write? X is equal to 3 zeros are 0, 3 5s are 15, 1, 18, 19. So 1950 into 10 to the power of minus 9 into d divided by d. So this is the first one, they had given the value. Now the second question is, what is the least distance from the central maxima from the bright fringes due to both the wavelengths coincide? So what is the least distance? So here what is nothing but what is the solution? We have to do it. So first, what is the formula? X is equal to n lambda d divided by small d. Okay. So here this is nothing but named as n1 and this is nothing but lambda 1. So similarly, x2 is equal to n lambda 2 divided by small d. n lambda to d divided by small d. So when they coincide, they said least distance from the central maximum where the bright fringes due to both the wavelengths coincide, they said. So from here, what we have to say here, lambda 1 they are given as 650 nanometer. Lambda 2 is nothing but what? 520 nanometer. So what is they are saying? X1 is equal to X2, both coincide. So what is the value? You should write it n lambda 1 d divided by d is equal to n lambda 2 divided by small d. Small d, n cancel. Sorry. So this is n1, this is n2. So this is n1, this is n2. So dd is not given, so it is cancelled. So from here what I should write? n1 by n2 is equal to lambda 2 divided by lambda 1. So what I should write? Lambda 2 is nothing but 520 nanometer divided by 650 nanometer. So nanometer cancel. So here what happens? 0 0 cancel. So n1 by n2 is equal to 52 divided by 65. So what is the value? You should write it now here. So here 13 4s are 13 5s are, right? So what you should write now here? n1 by n2 is equal to 4 by 5. So the meaning is n1 is equal to 4, n2 is equal to 5. So here what happens? Bright fringes are nothing but n1 is 4, n2 is 5. Okay.